Hello, friends. Good evening. Welcome to Eastern Academy. And we are discussing about electrical as part of embedded system programming. And we are in the session 4. In this session, we are going to discuss about what is ground, earth, negative voltage, no voltage, zero voltage. There are so many terminologies we use in the electrical and electronics. Let us make to understand these things very clearly. The terms are all very important. Otherwise, you will think everything mistake. Okay, so let's go to the board. I have drawn a battery and a resistor. Sorry, one resistor. We put one resistor. Okay. Generally, in the industry, if you have to draw like this so big, the circuits become so complex. So what they have done, they have removed this. They have removed this. And they made this as a V voltage. And this point, they put a symbol. This is called ground, or we can call common point or reference point. You understand? So this point, the battery, this negative is connected here and positive is connected here. In this case, we make negative as a common point. Understand? Now this, if this is 10 volts, this becomes 10 volt. So this is called ground. Understand? So if I mention in a circuit, let's say I have a resistor like this, two resistors. If we ground this, if we make this one as a V1, if we make this as a V2, that means that if I write like this V1 and V2, the V1 between these two difference and the V2 is between these two difference. So if I mention, see, you know that for voltage is potential difference. This you know very clearly. Voltage means potential difference. Difference is very important. If I say difference, there should be 2 points. When I have a 2 points, then how do I make here a voltage on a single point? So in your circuit, if you make a single point voltage, the other point is the ground. Understand that. This has to be understood very clearly. Its ground is called common point. Common for everybody, for all the people. I may be having a very big circuit. See that. I may be having a very big circuit. If we ask you here, what is the voltage at point X? That means that if there's a 1 point, now the voltage is between this point and this point, the difference here. This is called Vx. So when I say this is, we take the common point is this. So understand that. So it's not between these two resistors. This when I mentioned 1 point voltage, The other point is always the ground or common point. Now let me ask you a question now. Then you will be able to let me see that how do you answer. I have two resistors, and this one is 9 volt. This one is 3 volt. This one is 5 ohm. This one is 1 ohm. What is the voltage here V naught? Can you tell me? What is V naught? If you can give an answer in 1 second, you are the greatest guy. If you could give an answer, right answer, give me answer in, not in everyone, private mode. Don't give an answer on, if you give an answer in 1 second, it's already gone. But the moment I draw a circuit, you should give an answer to me. What is the answer now? Anybody? Don't afraid to give an answer. That's the only way you learn. That's the only way you learn. If you're afraid to give an answer, you don't learn. No, I asked V naught is equal to how much? What is the voltage? What is the voltage? I asked what is the voltage? $12. I got one answer, 12. I told don't give an answer on everyone. Don't give an answer on everyone. I told, but you are giving the answer on everyone. Understand? You confuse. You send a direct message. That's why I don't enable to everyone so far. I enable to because this is the reason. When you give an answer, you give it to everybody. Now let us go very simple Ohm's law. Let us go by Ohm's law and solve the problem. What is Ohm's law? Ohm's law is V is equal to IR. Am I right? Now, what is voltage? Voltage is potential difference. Voltage is potential difference. Let's say this is point A, this is point B, this is point C. Now, what is the voltage between point A and C? We normally mention VAC. So between A and C, because voltage is required 2 points. A and C, 9 volt and 3 volts. The difference is 6 volt. Because I told you that is a potential difference. So the difference between A and C is 6 volt, 9 minus 3. Now, what is the resistor here? Both are connected in series. So the equivalent resistor, let me draw it on different color. The equivalent resistor is 5 plus 1, 6 ohm. So V is equal to IR. So I is equal to V by R. It's equal to 6 by 6. So the current passing through this is 1 ampere. So the current passing through this is 1 ampere. Now, what is V1? V1 is I1, I into R1 is equal to I is 1 ampere. 1 ampere into 5 ohm is 5 volt. And here is 1 ohm. 1 ohm into 1 ampere is V2 is equal to I into R2 is equal to 1 volt. Now, across the resistor is 1 volt. This point is 3 volts. So this point is 4 volt. Either you can say 9 minus 5 or 3 plus 1. So V naught is equal to 4 volt. V naught is equal to 4 volt. If you don't get it, solve it. Watch this thing, how I have done it. This is a big problem we have. This is a big problem we have. Am I right? We do not use Ohm's law properly. I just use only Ohm's law. You tell me where I have done a mistake in the Ohm's law. If you don't understand any portion, you can tell me. I'll tell you one by one. Now I'll draw the circuit. I will solve the problem one by one. You tell me which step you don't understand. I have 2 resistors. connected in series. The top point is 9 volt, point A. Point C is 3 volts. Point B, I'm asking what is the voltage. And this one is 5 ohm. This one is 1 ohm. Now I do step 1. Step 1 is very simple. I make these 2 points. These 2 points I make. The voltage difference, voltage across A and C. So 6 volt minus 1 volt. Sorry, 9 volt minus 3 volts equal to 6 volt. This is step 1. Step 1. If you don't understand step 1, let me know. Step 2 is a resistor across this. The resistor across this. I connected both are series. So 5 plus 1 is 6 ohm. This is 0.2 because they are series I added. That's why I told you R1 plus R2. 0.2. Third, I find out the current passing through this. I is equal to 6 volt by 6 ohm is equal to 1 ampere. This is the step of third step. How I'm just going by step. That's a trick. Now, fourth step is voltage across R1. V1 is equal to I into R1 is equal to 1 ampere into 5 ohm is equal to 5 volt. This is step 4. This is step 4. And here, this is V2 across the voltage. V2 is equal to I into R2 is equal to 1 ampere into 1 ohm is equal to 1 volt. This is step 5. V0 is equal to 3 volts plus across this because the potential is difference is this. V2 is equal to 4 volt. So this is the answer on 6th step. I got the answer on the 6th step. Now, if you don't understand any steps, 1 to 6, let me know which step you don't understand. And tell me why. Why you don't understand which step? Why? I made it 6 steps. Clear? Anybody? You have any doubt here? Now tell me. Which step you don't understand? How come you add V0 is equal to V1 plus V2? V1, V2 is across VAC, but I'm asking only here. I'm asking here V0 with respect to ground. The potential difference, please understand. Voltage is potential difference. V0 is equal to 9 volt minus V1 or 9 volt minus, or you can call this as a VA and VC. V0 is equal to VC plus V1. If you don't understand the difference, then there's a problem. Please understand here. I have two people. Understand, I have two people. This guy had about 1,000 rupees. There are 3 people. Let's have 3 people. Let's have 3 people. I put 3 people. Now this guy is having 1000 rupees. This guy is having 400 rupees. Understand? Now, this guy is more than 100 rupees. This guy is less than 400 rupees. Sorry, 500 rupees. This guy is sitting in between. This guy is sitting in between these two guys. One guy is having 400, that is 3 volts. One guy is having, so the difference is 600 rupees. The difference is 600 rupees. He is 100 rupees more than that, means 400 plus 500. This guy is having 500 rupees. To make it think simple, you can make this as a for 200. This as a 4, then it will become easy. Then this guy becomes 600. Now I'll put you one more problem. Then let's see that how you are solving it. Then you will know that. Try to solve one more problem. How quick you do that. You are confusing a lot. That is what I'm trying to say. I know that by asking a question, I know that this is you are confusing. This is 9 volt. Same thing. Tuck. Same problem. I just changed the resistance. So what is the V naught? No? Then you have to solve the problem at your home so many times. You need to practice a lot. Now I know that why you people are getting confused in the electronics and embedded system and all. The problem is the very basics, Ohm's law itself, you have a lot of doubts. You know, you are getting a confusion with so many things. Voltage is potential difference. Voltage is potential difference. So if you find the voltage V1 and V2, then you can find V naught because I given this point. So I have a person, 2 people. I say this guy is having 1,000 rupees. The difference is 500 rupees. You know, this guy is 1,500 rupees. That's it. Same thing here. No, this is not 2 volt. That is wrong. Somebody has given 2 volts. That is wrong. The voltage is 9 and 3. How come that the voltage? See, there are 2 people. There are 3 people. 1, 2, 3. There are 3 people. Okay, the trick here is the 3 people. This guy is having 1,000 rupees. This guy is having 400 rupees. This guy is in between. How can you say this guy is having 300 rupees? He could be either above 400 or below 1,000, in between. This point is 9 volt. This point is 3 volts. So this will be in between 3 and 9. Somebody has given a correct answer. Somebody has given a correct answer. The answer is 7 volt. If you don't understand that, watch these videos. I've given us steps. Solve, you yourself put up various questions and try to solve it. And don't think it's a joke. These are all very important concepts that the fundamentals you have to know that. How to apply the Ohm's law. Now, we discuss one more point. I have a battery of 5 volt. I have another battery of 5 volt. I have another battery of 5 volt. This point is A. This point is B. This point is C. This point is D. Each battery is how many voltage? 5 volts. We connect them in series. Now, the beauty is, if I ask you the voltage, what is between A and B? Then you can say that A and B is 5 volt. The difference is 5 volt. What is B and C? Between B and C, there is 5 volt. VCD is 5 volt. Very simple. If I ask you what is A and C, 2 batteries. So 5 plus 5, 10 volts. If I ask you what is BD, you can say it is 10 volts because the point B and D, there are 2 voltages. Now, if I ask you what is A and D, then you will say that 5 plus 5 plus 5 is 15 volts. Correct. Here is you have to understand very important now. Now I ask you all this VAB, VBC, VCD. Now can somebody tell me what is the voltage VA? What is VA? Can somebody tell me what is VA? You cannot, because I have not given the other point. Now what people say is that you make this as a common point. I make D as a common point. If you make D as a common point, if I say VA, that means that VAD. The D is the I don't mention. If I say VB, VBD. If we say VC, VCD. So now, this point, the voltage is 15 volts. This point, the voltage is 10 volts. This voltage is 5 volt. This point is 0 volt because VD is the same point, so it becomes 0 volt. So this common point is 0 volt always. Please understand. The common point is 0 volt. If I connect a wire to this point, I have a wire. If I connect the wire to this point, then if I ask you what is the, let's say this is called X. If I ask you what is Vx, 0 volt. If I connect the wire to this point, then the Vx is 5 volt. If I connect the wire to this point, Vx is now 10 volt. Understand? If I say that Vx, it means that V, X, and D, because D is a common point. Now let us take here. Let us do another small thing here. Let's see that how you respond. I have every point A, B, C, D. Now I make this as a common point. I make C as a common point. Now if I ask you what is VA, VB, VC, VD, how much? Can anybody? Can anybody? Please. I made now C as a common point. So if I say VA means VAC, VBC, VCD, VDE, DC. Now what is the voltages? What is VA? VA is, yeah, somebody has given a almost near perfect answer. Now I have only one doubt. VA means VAC. That is 5 plus 5, 10 volts. VAC is equal to 10 volt. Okay, sorry. VAC is 10 volts. Now, VB means VBC is equal to 5 volt. VC means VCC is equal to 0 volt. Because there is no difference, same point, subtract. But here is a trick. VDC. I am not asking VCD. I am asking VDC. That means that this is minus 5 volt. Please understand. This minus 5 volt not 5 volt. Correct. Somebody has said perfectly correct. That is minus 5 volt. Thanks. Now you understand about what is minus voltage. Okay, because I have 3 people. If we make this guy's 100 rupees, this guy having 500 rupees, this guy is having 800 rupees. This guy is 300 rupees more than this guy. Whereas this guy is 400 rupees less than 1, 2, 3. Person 2. P1, P2, P3. So this guy is less than P2. So P3 is 400 rupees less than P2, whereas P1 is 300 rupees more than P2. So more means plus, less means minus. Now you know that what is negative voltage. There's nothing called negative voltage. Now the same thing, think of it. If I make a circuit, if I make this B as a ground, B as a common point, makes B as a common point, then what happens? The B as a common point, what happens? Now VA is equal to VAB is equal to 5 volt. VB is equal to VBB, same point, 0 volt. VC means VCB is equal to minus 5 volt. VD means VDB is equal to minus 10 volt. It's 2 batteries. So a ground is common point. Please understand. Ground is common point. Ground is a common point. Correct. Somebody has given the right answer. Now you understand. For example, when I construct a building, I can make any floor as a ground floor. I may be having 2 floors for car parking. I can make this as a ground floor. In India, we have a ground floor is different. In US, the ground floor is different. In India, we call this is the ground floor. This is the first floor. In US, this is called first floor. This is called bottom one is called ground floor. So the ground is a, please understand, there are 2 different terminologies. One is called ground. One is called earth. The ground is relative. The earth is absolute. Understand the difference between absolute and relative. Earth is always 0 volt. Earth is, when the moment you say earth, it is always 0 volt. That is what your actual earth, where it has unlimited metals, unlimited amount of electrons. That's why earth is always 0 volt. But the ground can vary. You cannot say that ground is, that's why we call ground as a common point. VD, if you build a connected, if your bulb is connected between VD and VB, not VD and VB, point B and point D. If you connect a 10 volt bulb, if you connect a bulb at 10 volt, then this guy will glow. It's the thing, that's the resistor. Resistor don't have any path. Resistor, the current can flow this way or this way. Doesn't matter. The bulb will glow. You give a potential, but the current will flow from here to here. That is same. That potential difference is no difference. Only thing is we represent this. But understand, a wire which is not connected. You buy a small wire which is not connected, and I have a battery and I have a ground, and I connect a wire to this pin. Understand, there are two things. I have a wire which is connected to the ground, and I have a wire which is not connected. I use a meter, I use a voltmeter and measure this point and this point. What is the voltage you will get? You will say 0 volt. But that is not 0 volt. That is a meter shows 0 volt because there is no current. But this is actually called one wire which is not connected is called no voltage. This is called 0 voltage. So you have to understand the difference between 0 voltage and no voltage. They are very, very important in our embedded system design. All the microprocessor, microcontroller, you cannot leave a pin on no voltage. But same way, you are not supposed to see. I take a wire here, I connect to this. This is fine. Here, no voltage pin can be connected with any voltage. So you can supply any voltage to no voltage. Your neutral is different. That is coming under the AC. I'll tell you what is neutral. I'll tell you what is neutral now. After this, I'll tell you. Okay. Actually, neutral is not required. I'll tell you why they bring a neutral, how neutral can be avoided. That's right. So understand now. So no voltage wire can be connected to any voltage. That is right. Perfectly right. I have a battery here. I have one more battery. Ground is connected. And this one is 10 volt. This one is 5 volt. This one is 3 volts. Understand now? Now, I can connect to this. This is legal. This wire become now no voltage to 5 volt. I can connect this wire. Now no voltage become 8 volt. I can connect this one. Now no voltage becomes 10 volt. You understand now? These are all legal. But this is illegal. This is illegal. I connect this one to this one, then you are shorting. This is illegal. Please understand, you can never connect any voltage to 0 voltage. That is wrong. This is illegal. But no voltage can be connected to any voltage. So that is the reason no voltage plays a very vital role. No voltage can play a very vital role in our system design. So the trick is that people ask, what is earth and neutral? Actually, what happened is this. When they, the generating session, they earth the one wire, negative one, and the positive one comes to you. This is called phase. And in your substation, there's a transformer. And there's a transformer. This one, they ground it. And this they given to your house. Your house, this is called phase. This could be high voltage. Let us assume that 11 kV. I'll explain to you that why the 11 kV now, later, when we are discussing AC. This is 230 volt. At your house, if you connect it to the earth, and you put a bulb here, this will work. This will work. But unfortunately, you may not do the earthing properly. If the earth is not proper, that gives you some resistance. Then there'll be a lot of energy wastage. For that reason, what the people do, the substation, EB station, they give you a wire called neutral. You need not have to have a at your home earth. You just have a neutral alone. But neutral is nothing but ground at substation. You understand what is neutral now? It is nothing but a ground. So earth, sorry. I'm confusing. It's called earth. We are earthing at earth. These two terminologies are always confusing people, earth and ground. Even I have confused now right now. You understand? So the neutral wire which comes to your house is nothing but a earth. But the thing is that neutral, yeah, if you cut the neutral, then there's no circuit close. Then your bulb will not glow. I may not know that what is maybe neutral cut, what you're asking. I never heard neutral cut means this is what I know. Neutral open. I don't know neutral cut. Maybe some terminology which I might have forgotten. I did electrical about 40 years back. So 83s, think of it. I've not touched electrical afterwards. So please, if I'll find out the net, and I also will search a net. Okay, and if you know the answer, let you know. So is it clear now? What is neutral? Neutral is nothing but is a earth, but connected at the substation. That's clear. That's the reason. So now I will tell you the one small application of Ohm's law. You'll be thinking that why we need to have in the generating station at Mettur or wherever it is, they step up transformer. They step up. And at your substation, they will step down and give it to you. This is your house. And this is, let us assume that 230 volts they generate. And they step up to, let's say, 2300 volts. Now, first we assume that we don't do that. We don't do that. From the long cable, I connect this one. So same 230 volt comes to you. And you are using a 2300 watts heater. Then the current is V by I, 230 by 230 volt, about 10 ampere. The current passing through is 10 ampere, assuming. Now, the resistance from that to here, if it is 1 ohm, assuming only 1 ohm, I'm assuming, from Mettur, where they do that, to your house, the wire is giving you 1 ohm. Then the current is 10 ampere. 1 ohm into 10 ampere, the drop is 10 volt here. So you get here 220 volts. You get here 220 volts, but your equipment gives you 230 watts, 2300 watts at 230 volts, but you are giving 220 volts only. So the heater will not give you proper heat because you are not giving the rated voltage. You're giving less voltage. So if you give less voltage, you give less power. Understand? The resistor is fixed. The bulb's resistor is fixed. Any device R is fixed. V square. If you give 230 volts, then more power. If you give 230 volts, less power. Understand? So that's the way it happens. Now do the same thing. What I do here is I use a transformer. I convert it to 230 volts to 2300 volts. And here also I'm getting 2300 volts. And once again, it become 230 volts. Understand one important thing. The transformer, nobody can destroy or create energy. Energy can never be destroyed or created. They can only transfer. 2300 watts, am I right? That comes here. But here 2300 watts at 230 volts. So 10 ampere. But here how many voltage? 2300 watts. So because of that, the current become 1 ampere. Understand now? Now the current is 1 ampere. So the drop is 1 ampere to 1 ohm, 1 volt. So 2300 volts, when it comes here, it become 2229 volt. At this point, 2229 volts. Understand? Sorry, 99. It's dropping only 1 volts. 2299 volts. But the transformer is stepping down. I get now 229.9 volts. See here, previously I got 220 volts. Now I'm getting 229.9 volts. Drop is only 0.1 volt. Suppose if I increase from 230 volts to 2300 volts, 23,000 volts or 23 kV, then this drop will be still less. If I go to 230 kV, then the drop is still less. So based on the step up, my voltage drop is reduced very minimal on the wires. By increasing the voltage, I reduce the current. So I can make a smaller cable also. The voltage will be dropped. So this is what the war between Edison, Tesla war. Go and read the net. Edison Tesla war is one of the beautiful thing happened on the technical history. Finally, this guy is the one, Tesla won. This guy got defeated on this aspect. Tesla won he is a great man. Tesla is go and read about Tesla, you know. That's why Elon Musk has given a car name as Tesla. Tesla is a great man. No, why I'm telling you, why I told you this is nothing but a Ohm's law. I just prove it to you nothing but a Ohm's law. So the power of Ohm's law is everywhere. The power of Ohm's law is everywhere. So we will discuss about the AC, and we are not discussing about the electrical class, but still, if somebody wanted, I can share that lectures. We have done it on AC and all. We have taken the classes on analog electronics. I can share the analog electronics class, which is there in the Google Drive. If you really want, I can share that. I don't share it to everybody because it confuses everybody. Those who are really interested, wanted to learn analog electronics, I can share the topic. Okay. So if you have any doubts, let me know. We have explained about maximum things, that is series and parallel circuit, and we discussed about all about what is ground, common point, and what is earth, absolute point. And what is zero voltage? Connected to common point. And what is no voltage? not connected to any source. Then we have discussed about negative voltage. Measured with common point. So if I give a single point, understand always, if I give a single point, VA or VB, the other point is ground or common point. That's the reason we don't mention it, the other point. Always if I do a single point voltage, that means other point is ground. So these things has to be clear to you. So this videos, go and watch it once again. And take the test in an app and take 3 days. Take every day. If you score 10 out of 10 for 3 days continuously, I'll be happy. Any doubts, anything else, you can ask me now. If you have any doubts, you can ask me now. But this is very important, please. Before coming to Monday, electronics lecture, that will change your full idea about electronics. So the electronics, what do you think? The electronics, what you're discussing is a bit different. So we will discuss about all the very fundamentals about electronics on the coming Monday onwards. There'll be 4 sessions, but not digital electronics, the electronics. So please understand that is very, very important. So this electrical knowledge, what we discussed on the 4 days, is very important to understand about electronics. So if you have attended lectures without proper understanding of this electronics, you will have a problem once again. We always try to proceed. You have 3 days. You have 3 days. Yeah, for you, I have not shared the app. I'll share the app. Correct. Sorry. For everybody, I put it on the group. Your name is not added. I'll add it and let you know. Any other doubts? It's all very simple, but it requires practice. See, the thing is that if you wake up at night, 12 o'clock, you should be able to solve the problems. Practice every day. Practice every day. 5 minutes, 10 minutes. I'm not asking about 24 hours, man. I'm asking only 5 minutes, 10 minutes. Solve one problem every day. You're done. I'll bet. You don't know the power of this. These things will get you the huge opportunity in the industry. Entire EV industry is based on this. If you don't understand, if you don't understand this, you don't understand any electrical. Understand? This is a very, very basics. Okay. I hope I made the point clear. I did my work and you have to do your work. So with that, we complete the electrical session. This is what electrical needed for your embedded system. Not too much. About we said how many hours? 8 hours. Enough. 4 days. 8 sessions. Enough. You'll be able to get to know this perfectly. But if you know how to use this, then you will see wonders. Okay, then stop the recording.